guys, it's Liana and I will discuss The Rhythm of Life, Chapter 7 of Nature's Numbers by Ian Stewart.
Dali lang gid. Ano na sang rhythms of life, nature's numbers man?
Really, nigga?
Good question, Nico. According to Ian Stewart, nature's numbers are the deep mathematical regularities that can be detected in natural form. It appears to us that the universe is structured in a deeply mathematical way. In Nature's Numbers, Stewart admirably captures compelling and accessible mathematical ideas along with the pleasure of thinking them. This chapter explains math concept behind rhythm and patterns found in locomotion and synchronization of animals and insects. In Nature's Numbers, Ian Stewart presents more, each charming in its own way. He shows, for example, how the oscillations of fireflies follow the same mathematical rules as the gaits of the horses. Let us now proceed to another topic, which is called the gait analysis.
What is gait analysis?
Gait analysis is the systematic study of animal locomotion, more specifically, the study of human motion using the eye and the brain of the observers, augmented by instrumentation for measuring body and movements, body mechanics, and the activity of the muscles. Gait analysis is also used to assess and treat individuals with conditions affecting their ability to walk. It is also commonly used in sports biomechanics to help athletes run more efficiently and to identify posture-related or movement-related problems in people with injuries. For example, walking. Each leg hits the ground 1/4 of the gait cycle after the previous leg. So the central pattern generator must have a symmetry that naturally leads to these quarters period phase shifts. There is also a left-right symmetry. Putting all of the information together and making some reasonable assumptions, it turns out that the central pattern generator should have the same symmetries as two loops of four identical components linked left to right. It need not have this form in a literal sense because other arrangements can have the same symmetries. But even so, we can make some predictions about the motion that have been verified experimentally.
Dali lang gid.
Oh, no, 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 no.
You might wonder, what is a central pattern generator? Well, it is the neural circuitry that generates the rhythmic electrical signals that in turn stimulate and control the limb's activity. Biologists call such a circuit a CPG, which stands for Central Pattern Generator. A central pattern generator, or CPG, is a neuronal network in which interconnected excitatory and inhibitory neurons produce an oscillating rhythmic output in the absence of sensory feedback. CPGs play an important part in motor behaviors such as breathing, swimming, and locomotion. We are now done with gait analysis and central pattern generator. So now, let's talk about the concept of oscillation. Oscillation refers to the repeated back and forth movement of something between two positions or state. An oscillation can be a periodic motion that repeats itself in a regular cycle, such as a sine wave. A sine wave is a wave with perpetual motion, as in the side-to-side swing of a pendulum or the up and down motion of a spring with a weight. An oscillating movement occurs around an equilibrium point or the mean value. It is also known as periodic motion. A single oscillation is a complete movement, whether up and down or side to side, over a period of time. Oscillator is a unit whose natural dynamic causes it to repeat the same cycle of behavior over and over again. An example of it is a person walking back and forth, pacing up and down. Its motion results a combination of two constraints that creates repeated pattern of actions. We are now done with gait analysis, central pattern generator, and concept of oscillation. So now, let us talk about a concept that is linked to oscillation, which is called Hopf bifurcation. In 1942, the German mathematician Eberhard Hopf found a general mathematical condition that guarantees such a behavior. In his honor, this scenario is known as Hopf bifurcation. The word bifurcation is used because of a particular mental image of what is happening, in which the periodic oscillations grow out from the original steady state like a ripple on a pond growing out from its center. The physical interpretation of this mental picture is that the oscillations are very small to start with and steadily become larger. Hopf bifurcation can be seen as a special type of symmetry breaking. The symmetries that break relate not to space, but to time. Time is a single variable, so mathematically it corresponds to a line, the time axis. There are only two types of line symmetry, which are translations and reflections.
What does it mean for a system to be symmetric under time translation?
Very good question, Nico. It means that if you observe the motion of the system and then wait for some fixed interval and observe the motion of the system again, you will see exactly the same behavior. That is a description of periodic oscillations. If you wait for an interval equal to the period, you see exactly the same thing. So periodic oscillations have time translation symmetry. Some animals only possesses one gait, only one rhythmic default pattern for moving their limbs. The elephant, for example, can only walk. When it wants to move faster, it ambles, but an amble is just as fast as walking. And the patterns of leg movements are the same. Other animals possesses many different kinds of gaits. For example, a horse. At low speeds, they walk. At higher speeds, they trot. At top speeds, they gallop. Some insert yet another type of motion, a canter, between a trot and a gallop. And that is all. Always remember the rhythm of life includes central pattern generator, gait analysis, the concept of oscillation, and Hopf bifurcation. Thank you for listening throughout the end of the vlog.